Let's go to another scheduling, which is called priority scheduling. Now, what is a priority scheduling? So every process will be attached with a integer, which is called priority. Okay, so every process has how many things? So it has process ID, which is also called process number. Then it has the burst time. It has the arrival time. All these are mentioned, and we have seen in the earlier examples that all three are mentioned. Now, apart from that, we have another attribute of the process that is also available in this particular scheduling is called priority. So priority is given. So priority is nothing but some sort of integer, and that integer signifies that how much priority is given to a particular process. So a process is a higher priority, maybe the integer number is higher, or if the smaller priority, so maybe the integer number is smaller. It depends upon book to book, right? So in Galvin, because this slide is from the Galvin book, so in Galvin, it is written that if we have a smallest integer, it means it has the highest priority. It means, let's say we have process 1, process 2, and process 3, and we find it out like process 1 has the priority 1, process 2 has the priority let's say 5, and process 3 has the priority 2. So if we want to put in a ascending order of the priority, so highest priority is P1, then this is the highest priority, then P3 has the priority, and then P2 has the least priority. So it will be like this. So it says that smallest integer equal to higher priority. So this is high and this is low. In some book, it says that highest number equal to highest priority. So in the question, they will give you that which particular integer signifies high priority and which particular integer signifies low priority in the question. So it will be given. Now, this particular priority scheduling is of two types. What are the type? Either it will be preemptive or non-preemptive. So we know the meaning of preemptive, right? So what is the meaning of preemptive? The meaning of preemptive is if a process is executing into the CPU and a new process arrive into the ready queue which has the higher priority. So the lower priority process which are running into the CPU will be stopped, and it will be taken back forcefully into the ready queue, and the new priority which has the higher process which has the higher priority will be given to the CPU. That is called preemption, right? Means forcefully we are deallocating the process and putting into the ready queue. That is preemption. Non-preemption means, the meaning of non-preemption means if a process will get the CPU, no matter which process came into the ready queue, the process which are running will run its all burst time, execute, and go to the terminated state. Then only other process will get the chance to execute into the CPU. That is called non-preemption or the non-preemptive. So that part is clear to all of you, I think. We are learning this preemption and non-preemption for a bit longer period of time. Now it says that shortest job first is priority scheduling, where priority is the inverse of predicted next CPU burst time. So it says that whatever we have learned about shortest job first algorithm, in which we choose those process which has the least CPU burst time, right? So which is having the shorter burst time will pick that one. In the same way, in the priority queue, which has the least number as a priority will be taken as first, because it says that smallest integer is the higher priority in this particular, according to this book. Okay, in different book it is opposite, means higher integer will higher priority. So it doesn't matter to you. What matter is the priority queue. The criteria for the priority queue is priority is the criteria. What is the tiebreaker here? So the tiebreaker here would be arrival time. If two process has the same priority, so we'll choose which process came first. And this priority scheduling, generally it is a preemptive scheduling. Generally it is a preemptive scheduling. We can also make non-preemptive scheduling also. Okay, so we can make non-preemptive scheduling, but generally it is preemptive scheduling. Now the problem of starvation is also there. How it is there? That low priority process may never execute. Means it says that higher priority will get the chance. So let's say if the process is running, which has the higher priority right now, and a new process came which has a more higher priority than which is running, so definitely the running process will be taken out from the CPU if we are using preemptive flavor of priority scheduling. If we are not using the preemptive flavor of priority scheduling, if you are using non-preemptive priority scheduling, then what will happen is that process will execute at burst time, then the new process which has the higher priority will get the chance. Again, let's say at some point of time, again a process came which has the higher priority, so that process will be getting the chance. So the meaning is the process which are existing into the main memory, means the process which are ready to execute but having the less priority may never get the chance of execution, because new higher priority processes are coming into the system again and again. So that problem is there, which is called starvation problem. What is the solution for that? Solution is aging. Aging means as time progresses, increase the priority of the process. Means if a process came at T0 time and at T5 it is not getting any CPU till now, so what we'll do is we'll increase the priority of that particular process. So that if we'll use the aging solution, then starvation somehow we can reduce. So that is the solution for starvation in priority scheduling. But starvation can come. If we are not using this solution, so definitely starvation will come. Now, if you know that what type of scheduling it is, so let's go and solve some of the problems related to priority scheduling. Okay. So in the priority scheduling, what are the criteria? As I told you, the criteria is priority. And if priority is same for two process, so we'll take as a arrival time as a tiebreaker for that. But priority is the main thing here. Now, here is the example for that. Let's talk about this example. We have process P1, P2, P3, and P4 and P5. So we have 5 processes. The burst time is given, priority is also given. We consider that arrival time for all the process is same. Means at time t0 all the processes are available that we are considering for this particular question. Maybe there are the question where the arrival time was given, that also will solve. Let's solve this particular problem first. Now we have 5 processes available. Priority is also given. So according to this book, which is having the highest priority? So definitely smaller integer has the highest priority. Okay. Smaller integer has the highest priority, and then we'll pick up that this process has the lowest priority. So based on that, we'll just solve this particular problem. Now for that, let's make the Gantt chart. Now in the Gantt chart, because at time t0, all the processes are there. So P1 is there, P2 is there. So where these processes are? These processes are in ready queue. Okay, these processes are in ready queue. So P2, P3, P4, P5. We cannot say queue it is, but there is some ready state, right? So in the ready state, they all processes are there. 1, 2, 3, 4, 5. So we have 5 processes which are available. Now all those processes will sort them based on their priority. So what we do, we'll sort them based on their priorities. How we'll sort it? So we'll put some sorting algorithm on that, and we'll make the queue. So this will become your ready queue. So this particular scheduling algorithm will sort it based on the priority. So which is having the highest priorities? Definitely P2 has having the highest priority. Then after that, P5 has the priority. Then P1 has the priority. Then P3 has the priority. And at last, we have P4, which has the priority. So based on the priority, we'll just arrange it. So now you know that how this queue work, right? So which is having the first means which are available at very first will be deleted first, and then it will be go on like a queue, right? So who is the first one will be serve first. So first come first serve basis will serve it. So definitely P2 has the highest priority. So P2 will be executing first, and it will execute all its burst time, right? It is not going to come out, because in this particular scheduling, we are assuming that no processes are coming in future. No processes are coming in future. Only these 5 processes are there in the system. So P2 is the highest priority with 1. So it will be there at time t0 because all the processes are available at time t0. And because the burst time is 1, it will be execute up to 1. P2 is over, then P5 will be get into the CPU and it will execute. The P5 priority is 5, so it will go up to 6. Now after that, P5 is finished, P1 will come into the system. P1 has the burst time, let's say 10, so it will execute up to 16. Okay, there was some issue. So where we are in the Gantt chart. Okay, so we are in the Gantt chart here. Now we have executed P2, P5 because P2 has the highest priority, then P5 has after that the highest priority, and then P1 we are putting because it has the priority P, which is the highest one right now. After that, P1 will be finished its execution, will execute P3. P3 has the priority 4, which is the burst time is 2, so it will execute up to 18. After that, at last, we are going to execute P4 with the burst time again 1, so 19, right? So this is how we'll we'll make the scheduling of all these 5 processes. Now let's find out our time. So we have different times, right? So what we have completion time, we have turnaround time, and we have waiting time. So we'll find out all these things for process 1, process 2, process 3, process 4, and last process 5, right? So completion time of process 1, we'll find it is 16. Completion time of process 2, we find out it is 1. Completion time of process 3, we find out it is 18. Completion time of P4 is 19. And completion time of P5 is 6, right? What is the turnaround time? Completion time minus arrival time, because the arrival time is same for all. So it will be same as completion time. The turnaround time will be same as completion time, as arrival time is same for all. Okay. Now let's go to the waiting time. It's turnaround time and burst time. So turnaround time is 16, burst time is 10. It will be 6. Turnaround time is 1, burst time is also 1. It will be 0. Turnaround time is 18, burst time is 2. It will be 16. Turnaround time is 19, but burst time is 1. It is 18. Turnaround time is 6, and the waiting time is burst time is 5, so the waiting time will be 1. So you see that the higher priority will get the chance earlier, and it doesn't have to wait for a longer period of time. So because the higher priority is P2 has the highest priority, so P2 doesn't have to wait, right? Now, if we'll talk about the next higher one, which is P5, so you see that P5 also having the least least other than P2. So we have the waiting time, which is very less here. And you see that who is having the highest waiting time? So the highest waiting time is for P4. You can see here, because it has the lowest priority. That's why it is having the highest waiting time. So this is how the algorithm priority based scheduling works. If you'll find out the average waiting time, so the average waiting time will be 6 plus 0 plus 16, it will be 22, 22 and 18, it will be 40, 40 plus 1, it is 41 divided by 5. So it will be 8.2, which is coming. So this is how we'll find out the waiting time, average waiting time of the scheduling algorithm, right? Now, could you tell me which type of algorithm it is, preemptive or non-preemptive? So this particular example is the example of non-preemptive. Okay, so it is actually based on your arrival time. If we have different arrival times, so definitely it will work as a preemptive. Otherwise, it will work as a non-preemptive. So this is which type of scheduling we have done? We have done non-preemptive type of scheduling, because we are not taking out any of the process out from the CPU. See, when P2 came, it will execute its all. When P5 came, it will execute its all. When P1 came, executes. P3 came, executes. And P4 came, executes. So all the processes are executing its burst time into the CPU. Let's see another example where we have to do preemptive scheduling in the priority scheduling. Preemptive type of scheduling. So in this, we'll use preemptive. Okay. So these two are there. So criteria is priority and the type is preemptive. Okay. Let's take one example in that particular regard. So I request all of you to solve along with me. So we have process number, priority, then we have arrival time, then we have burst time. So all these are given. Okay. So how many processes are there? We have 1, 2, 3, 4, 5, 6, and 7 processes are there. What are the priority? We have 2, 4, 6, 10, 8, 12, and 9 are the priorities. What are the arrival time? Arrival time is very simple. It is starting with 0, 1, 2, 3, 4, 5, and 6. These are different arrival time. Now, what are the burst time we have? We have 4, 2, 3, 5, 1, 4, and 6. So these are all different burst time which are given. Now, in the later part, we are going to calculate our turnaround time, and then we have waiting. So all these things we'll calculate after some time. Okay, so let's go into deeper and create the Gantt chart. So for creating the Gantt chart, let's make the chart, and we have processes. Okay, so what are the processes that are available? So let's go at time t0. At time t0, what is the process that are available we have? So we have only process P1 which is available at time t0 because arrival time is 0 here. Now because we have only one processes are available at time t0, so we doesn't have to compare to anything. Before that, let's talk about the priority. So you see here in this particular question, high number has high priority and low number has low priority. So you can see here, this 12 has the higher priority and this 2 has the lower priority. So it will be given in the question that which one is the higher priority and which one is lower priority. So you can see here, the lower priority is P1, but P1 has arrived and no else processes are there in the ready state. So P1 will execute and it will execute up to 1, right? So at 1, what are the other processes that are available? We have process 2 which is available. Now, once the process 2 is available, now we'll find out between process 1 and process 2, which is having the higher priority. So you can see here, because higher number has the higher priority, so here P2 has the higher priority. So we'll take out the P1 because P1 has lower priority right now and put into the ready queue, and we'll give the chance of P2 into the CPU and will execute up to another unit of time. So at time T2, what are the processes that are available? It is P3, which is available. So we have P1, P2, and P3 all are available. Meanwhile, let's calculate its burst time. So how many burst time we have done here? One burst time we have done, 3 is left. For P2, one burst time we have done, 1 is left. Okay. Now P3 came at time time T2, and its priority is 6, which is the highest among all. So we have to give P3 a chance to execute into the CPU, and P2 will reach to the ready queue again. Now at another 1 unit of time, at let's say time T3, which process will be coming? That is process 4, which is coming, right? Now process 4 is coming. Let's talk about its priority. So priority is 2, 4, 6, and 10. So because P4 has the highest priority, P4 will get the chance for the execution. Now P3 has executed 1 burst time. So we'll just calculate it and we'll say 2 burst time is left. Now P4 will execute another burst time, that is up to 4. At 4, T4, P5 is also available. So we'll put P5 into the ready queue. Now at that part of time, we'll again compare the priority of all the processes from P1 to P5. So we found out that P4 has the highest priority till now. So P4 will continue its execution for another burst time, that is 5. At T5, you can see here that 6 has also arrived. So P6 has also arrived here. Now P6 has arrived here, and we have P1, P2, P3, P4, P5, P6 all are available because we haven't executed fully all the processes. So all the processes are available. When P6 came into the existence, now which is having the highest priority? Definitely P6 has the highest priority. So P6 will come here, and P4 will get taking out from the CPU and putting into the main memory. So P4, how many unit it has executed? 2 unit it has executed, P4. So how much is left? 3 is left. Now P6 will execute another unit of time, that is up to 6. So at time 6, P7 also coming into the ready queue. Now you can see that at this particular point of time, all the processes are available. So we have P1, P2, P3, P4, P5, P6, P7, all are available. And among all, which is having the highest priority? Definitely P6 having the highest priority. So P6 will be continue its execution, will not do any context switching, it execution up to how many? Because we have done 1 unit of time, so 3 is left. So we'll execute up to 9. Now P6 is finished. Now among P1, P2, P3, P4, P6, and P7, which is having the highest priority? So you can see that 4 is having the highest priority. So 4 will come here. How much is left for 4? 3 is left for 4. So we'll execute 3 unit of time, means we'll execute up to 12 for P4. Right? Now after that, P4 is finished. Now P1, P2, P3, P5, and P7, which is having the highest priority. So you can see here, P4 is finished its execution. P6 is also finished its execution. So among the rest of the processes, P7 has the highest priority as 9. So P7 will execute here. So P7 will come here and it will execute all its burst time, that is 6. So 6, all its burst time it will be executing, and 18 it will be executed. Now it will be done. Now among the rest of it, P5 has the highest priority, that is 8, and the burst time is 1. So P5 will come here into the CPU, execute 1 burst time, and at 19 it will execute itself. Now that now we have P1, P2, and P3 which are left. P1, P2, and P3. P5 is done. Among that, P3 has the highest priority, that is 6, and 2 burst time is left. So we'll execute P3 with 2 burst time to it. That will be 21. Up to 21, it will execute itself and will be done its execution. Right? Now after that, P1 and P2 is left. Now among P1 and P2, P2 has the highest priority and burst time is 1. So P2 will be executing here, burst time with 1, that is 22. And at last, we have P1 which is left, which is having the least priority. And the burst time was left is 3. So at 25, it will execute itself. So you can see here, this is how the execution takes place between all the processes through what scheduling? Through priority scheduling. And this particular scheduling is which type? Is of preemptive type. Why preemptive type? Because of the arrival time is given. And if the arrival time is given, we have to look forward for the priority. And if a new process came with the highest priority, definitely we have to give the highest priority process a time to execute into the CPU. So I think that is clear to all of you. Let's talk about the completion time for all the processes. So you can see we have to find out the completion time of P1. So the completion time of P1. So we'll start from the left hand side. From here we'll start and we'll start scanning. So from here we'll start. We'll find out P1 at first occurrence, and the completion time is 25. So we'll say 25 is the completion time. Now for P2, completion time is 22. So 22 is the completion time for P2. Now for P3, completion time is 21. 21 is the completion time for P3. Now for P4, so we are scanning here and we'll find P4 here. The completion time is 12. P5, again we'll start from the right to left and the P5 is there. Completion time is 19. P6, the completion time is 9 here. P7, the completion time is 18 here. So this is how we'll find out the completion time of all the processes. Now after that, we'll calculate the turnaround time. So how we'll calculate the turnaround time? You all know that what are the method to calculate turnaround time. So I'm just writing the formula for that. Turnaround time is nothing but completion time minus arrival time. Okay. So completion time is 25, arrival time is 0. So it will be 25. 22 and 1, it will be 21. 21 and 2, it will be 19. 12 and 3, it will be 9. 19 and 4, it will be 15. 9 and 5, it will be 4. 18 and 6, it will be 12. So these are all turnaround time of the processes. Let's go for the waiting time. So what is the formula for waiting time? It is turnaround time minus burst time is the equation or is the formula for waiting time calculation. It will be 25 minus burst time is 4. It will be 21. 21 minus 2, it will be 19. 19 minus 3, it will be 16. 9 minus 5, it will be 4. 15 minus 1, it will be 14. 4 minus 4, it will be 0. and 12 minus 6, it will be how much? It will be 6. So these are all the waiting time. You can realize here waiting time of P6 process 6 is 0. Why it is 0? Because the higher priority process doesn't have to wait for a longer period of time. In a contrast, if you see which is having the highest waiting time, so the highest waiting time is given to P1, which has the least priority. So the process which is having the least priority has to wait for a longer period of time. Process which has the highest priority doesn't have to wait, and it will get the chance into the CPU execution. Now we can calculate the average waiting time and the average turnaround. So all these things you can calculate by yourself. Now come to this particular scheduling. Here you can see that P1 is executing previously, then it will be preempted. It will be preempted. In the same way, P2 is executing, it is also preempted. P3 is executing and it has also been preempted because a new higher priority process came into the existence. Then P4 is executing, it is also been preempted after this particular point. Then P6 is coming because P6 is the highest priority, it will be executing all. Then P4 has the highest priority, it will be given. Then P7 has the highest priority, that is coming. Then P5. So you can see that at a particular point of time when most of the process came, means at that particular time, because at time T6 all the processes are arrived. So after that there will be no preemption. So it will be acting as a non-preemptive algorithm when all the processes arrived. Before that, when all the processes are not arrived, it is working as a preemptive algorithm. So you can see that overall it is a preemptive algorithm, but once all the processes come into the ready queue, then it will act as a non-preemptive scheduling algorithm. So you can got it. Now there may be the question like this. Okay, waiting time you are calculating. Very good. The waiting time is 11.4 is calculated by one student. You can calculate the waiting time and turnaround time by yourself. Now what I am saying is, if a question asked with the same question is given, but the question is asked like, you have to use non-preemptive algorithm. You have to use non-preemptive type algorithm to solve this one with priority scheduling. So what you have to do? So at the beginning, you have to use non-preemptive, because at the beginning we have used preemptive here. In that case, where it is written significantly, means explicitly it is written that you have to use non-preemptive type of priority scheduling, then from the beginning you have to use non-preemptive algorithm. It means if we'll solve the same thing with non-preemptive, so the Gantt chart will look like this. So I'm putting here only in one box. So here what we are using? We are using non-preemptive flavor of it. We are using non-preemptive flavor of it. And let's solve it using Gantt chart. So you can see here, my Gantt chart will look like this, where because at time T1, T0, P1 came, so we'll give the chance of P1 to execute itself from 0, starting with 0, and then it will execute all its burst time because it is a non-preemptive. So it will execute all its burst time no matter which process came. It will execute all its burst time at 4. So it will be done. Now, let me make it. Now at time P4, what are the processes that are available up to P5? So we'll compare the priority up to this. So at time T4, we'll see from process 1 to 5 which is having the highest priority. So we know that process P4 has the highest priority, so P4 will be given the chance and it will execute all its burst time. 5 means it will go up to 9. So you can see at time T9 all other processes are available, right? So other than P1 and P4, we'll compare the priority. So we'll find out that P6 has the highest priority, so P6 will come here, execute all its burst time, and done. It's burst time. After that, we'll consider P2, P3, P5, and P7. So P2, P3, P5, and P7. Among that, P7 has the highest priority, so P7 will come, execute all its burst time, right? After that, which one is left? 2, 3, and 5 is left. So 2, 3, and 5. 5 has the highest priority. So 5 will execute its burst time with 1. It will be 20. Now after that, P2 and P3, among P2 and P3, P3 has the highest priority. It will execute its burst time, that is up to 23, and then P2 will come and it will execute its burst time, which is 2, right? So you see the Gantt chart of these two type of algorithm. This is the Gantt chart of preemptive and this is the Gantt chart of non-preemptive. See, when a process will get the CPU, it is never coming out. It will execute itself, then only other processes which are available at that particular time will get the chance for the execution. In that way will be done. So you see these type of question also can be asked in the examination. So you have to be prepared and you have to see the question that which type of scheduling it has been asked and that scheduling is of which flavor, which is a non-preemptive or preemptive. If it is not explicitly mentioned, then you have to do it what that schedule is all about. Otherwise, you have to follow the flavor of preemption and non-preemption.